Hello GCSE Plus Year 9 students, this is Mr Wilm speaking. You may remember I met you when you first came to King's in January. I hope you're well and I hope your families are well too and your friends also. And I hope you've had time to think about some mathematics, maybe the weekly challenge we suggested you might enjoy. So this week's was about weighing things, weighing flour, or in this picture weighing sugar. And the challenge was you had the weights 2 kilograms, 5 kilograms, 3 kilograms, and which integer weights between 1 kilogram and 10 kilograms could you weigh using those weights. So obviously you can weigh 10 with 2, 5 and 3 on the left hand side and 10 balancing on the right. You can weigh 4 by having 2 and 5 on the left, making 7, balancing 3 and the mystery value being 4 on the right. So I just started playing around with this. I thought, well, I can weigh 1, so 2 and 3 are my kilogram weights in blue, and 1 is the bag of sugar. Similarly, I can weigh 2 kilograms bag of sugar in that way. I've got the 5 kilograms and the 3 kilogram weights and the 2 kilogram bag. Now, obviously, I could just weigh the 2 kilogram bag against the 2 kilogram weight, but I like this because it's slightly more imaginative, and I can do the same thing for 3. If I had the weights being 5 and 2, I would then weigh the 3 kilogram bag, even though obviously I could just weigh the 3 kilogram bag against the 3 kilogram weight. I could do 5 like that, as we've already said. So really I don't need to keep on drawing the picture. It's about what's on the left hand side, the LHS, and what's on the right hand side, the RHS. And so I just made a table, and I just thought, well, 3 on the left and 2 and x on the right, that means x would be 1, the bag of sugar. If I had 5 on the left and 2 on the right with x also on the right, then x being 3 would be the bag of sugar, and so on. If I had all 3 of them, 2, 3, 5 on the left, that would balance 10. And if I had just 2 of them, or the biggest 2 of them, 3 and 5, that would balance 8. 9 seems a bit harder, because once I've put down 3 and 5 to weigh 8, I only have the 2 left, so I'll jump from 8 to 10. So I think 9 is the one I can't weigh, because 3 and 5 is too small, and 2, 3 and 5 are too large. But really, having 3 on the left and 2 on the right, and 5 on the left and 3 on the right, and so on, really, it's like having 3 on the left and negative 2 on the left. Now, I know a negative weight is a bit of a strange idea, but bear with me. Or we could have 5 on the left and negative 3 on the right, and that would make a total of 2. If we had 5 and 2 on the left with negative 3 also, that would make a total of 4. So that would balance the 4 on the right. If I had 5 and 3 and negative 2, that would make 6. So that would balance 6 on the right, and so on. Now, the question we actually asked you was, can you weigh every integer weight from 1 to 10 using 3 weights? You can't do it with 2, 3 and 5 because you can't weigh 9, but is there a set of weights that will enable you to do that? And the answer is yes. Actually, there's more than one answer. So see if you can find one answer and indeed some answers, and then email your answers, plural, and of course your reasoning to us, and we look forward to sharing those in the near future. But I just thought a bit more about this problem. So this question about having 5 and 3 and negative 2, or 5 and 2 and negative 3, really what we're saying is, can I have a combination of, say, 5 being either negative 5, no 5s or 1 5, 3 either negative 3, no 3s or 1 3, i.e. just 3, or negative 2, 0 or just 2, on the left hand side, balancing anything between negative 10, which is made out of negative 5, negative 3, negative 2, or positive 10, which is 5 and 3 and 2, those numbers on the right, balancing those numbers on the left. Obviously, to make 0, we'd have no 5s, no 3s, no 2s. To make 7, we'd have 5 and 2. To make negative 7, we'd have negative 5 and negative 2, and so on. So how many options are there on the left-hand side? I've got 3 possible weights, each one in 3 ways. And how many options are there on the right-hand side between negative 10 and 10, including 0, but not including 9 and negative 9? And if there are more on the left than on the right, then that means there must be some duplication. And in fact, we know there's duplication. We just said 5 could be just 5, but it could also be 3 and 2. 3 could be just 3. It could be 5 and negative 2. So there must be more on the left. How many are there on the left? How many more are there on the left? And therefore, how many duplicates are there? That's something you might like to think about. And also you might like to think about what happens if we have different sets of weights. So if we have weights which are powers of 2, all on the left, say, what weights can we measure on the right? So 1 and 2 would give us 3, 1 and 4 would give us 5, 1 and 2 and 16 would give us 19, and so on. So just thinking, if I have these weights, powers of 2, what can I weigh? And then if I have also, instead I consider powers of 3, but this time perhaps have them on the left and the right, so I can have positives and negatives. So I could have -1 and 3 to make 2, or I could have -1 and -3 and 9, and that would make 5. So what do you notice, and can you explain it? So if you want to explore either of those problems using powers of 2 on the left or powers of 3 on both the left and the right, let us know what you find out. Again, share your ideas, share your reasoning to our usual address. Keep safe, keep well, and we look forward to sending you weekly challenge 2. Bye for now.